So now this is the box I'm talking about. It's actually containing the Raspberry. This is a light connected to it, and this is the light we want to control by the PC. I'm gonna walk over to the PC now. This is actually the web page that is published by the Raspberry Pi, which can make you turn on the light on or off. In this case we'll choose for the off mode. We'll click on the button to apply it, and hopefully you can see that the light went off. And the other way around is also possible. You can turn it on again, choose the on mode, click on the button below, and some time later it will go on. And that's something you can do with your smartphone as well. So you got your Raspberry Pi. Just a quick info on what it is. It is actually a PC. It's a very small PC, but it is a PC, personal computer. It's not doing Windows for many reasons. Main reason is that it's a bit too slow and not powerful enough to run something like Windows. But it does have graphics, graphic interface if you want it to have it, or it runs under Linux. This is what it looks like. This is actually a picture. In fact, the size of it is about the size of a credit card, meaning it's just 2-3 inches, I guess, on 2-3 inches, or like 10 to 8 centimeters, or whatever your unit is. But it's very small. It fits in the palm of your hand. Very small print, very small PCB, and you can actually get some idea on how big it is on some of the connectors. Like this is the USB port. It's got 2 of them actually. Ethernet connection, audio connector, so it gives you some idea on what the size is. Another thing I wanted to say is that it's like a PC, but instead of a hard disk, I suppose you could actually attach a hard disk to it, or even a USB stick. In this case, most people tend to use, or standard, it's equipped with an SD connector, which is at the bottom of the printed circuit there. So it's actually an SD card that's being used as a hard disk, and where you will actually store the operating system, or you can actually buy the SD card with the operating system already installed. And also the programming that you run. So whatever you wanna program and run, the SD card pretty much functions as a hard disk. Standard, I think it's about 2 or 4 gigabytes, not megabytes. I've been using in my application around, it's a card of 4 gigabytes, but I've noticed that it's only being used for about half of that, so it's plenty. You can actually put everything on an even much bigger SD card, but there's really no use for that. So whatever old SD card you have laying around is more than enough to have the operating system, and even the programming that we're doing, although that's even only a couple of hundreds of kilobytes, even not much more, I would guess. But we'll see about that. So what do you got on the Raspberry Pi? Which connections do you have? There's a LAN connection, which you can see here. It's an Ethernet port, plain Ethernet. I think it's 100 megabits per second. We'll be not using that afterwards. We'll be using the USB port, which is right next to it. In the USB port we will actually put in Wi-Fi stick. In this case, it's actually the model Wi-Fi, obviously the same name, because we want to make it wireless. We want to control the extension cord, but we don't want to have Ethernet cables going to it. But if you're doing it for another application, or you want to use the Raspberry and interface for other applications, you might just as well. Either way, you need an Ethernet connection. There's some LEDs. You'll see what they do if you power it up. Mainly it is a power up, and there's some Ethernet indications, which actually only work, I think, with the LAN. There's an audio connector. There's a video connector if you're using RCI. I haven't used it myself. There is an HDMI connector, which I have been using with a converter to attach it to a VGA monitor. We'll be using that through the programming, but you don't really have to. You can actually use a secure shell, as it's called. We'll come back to that if you want to use it. And eventually, once everything's installed, you don't even need a monitor whatsoever, so you can just control the lamp or heating or whatever, and you'll be using the interface of your smartphone or tablet to control it. So it's quite neat that it has it on board, but eventually you won't be using it. Then we have the power connector, which is micro USB, I suppose. It tends to get 5 volt DC power supply through that port, but as we'll see later on, we won't be using that connector for powering it up. We'll be doing it through the general purpose I/O connector, which is the one you see here. The drawing is not completely correct, I suppose, because it's not just the holes that are foreseen for the general purpose I/O connector, or the GPIO. It is actually with pins on it, so you can put a connector which is fabricated with a flat cable directly onto the pins that are on the real connector on a real PCB. I suppose I can show you here. This is the other way around, as you can see, but it's actually this connector. That is the general purpose I/O connector, and that is the one that we'll be using to put power supply to the Raspberry Pi, and also to put some LEDs and relay attached to the Raspberry Pi, which we're going to control later. So that's pretty much what the Raspberry Pi is, and we'll continue with the next scene.